chairman for this evening's proceedings. And my role is really look after the mechanics of the meeting and ensure that everyone has a chance to express their opinions and that you get a satisfactory answer to any questions or comments that you might make. I'd like to apologize for my voice. These August surroundings haven't stirred me to audition for Hamlet. I'm just nursing a bit of a cold. Bonsoir, mesdames et messieurs, et je vous souhaite la bienvenue à cette réunion d'information au sujet du projet du pont entre l'île de Prince-Édouard et le Nouveau-Brunswick. Mon nom est Jacques Painter et je suis votre animateur ce soir. J'aimerais prendre quelques instants pour vous expliquer l'ordre du jour et les modalités pour les discussions. Pour la plupart, les activités se poursuivront en anglais, mais si vous êtes plus à l'aise en français, gênez-vous pas, vous pouvez poser vos questions ou faire vos commentaires en français. I'd like to introduce the head table. It's a man that probably by now needs not much of an introduction. On the immediate right of the table is Mr. Paul Gianellia, the president of Straits Crossing, Inc. To Paul's left is Kevin Pittick, a senior project manager with Straits Crossing, Inc. as well. To Kevin's left is Jeff Barnes, the environmental manager for this project and with SCI. And the gentleman on the far left of the table is Frank Ross, who's a senior vice president with Fraser Brace, an associated firm with SCI. Our agenda this evening is quite straightforward. We'll have a presentation on the concept development, the construction and operation, characteristics of the bridge. Then Jeff will give us an outline of the environmental management plan, and then we'll throw the floor open to questions and answers. Before we get started, I'd like to make a few introductory comments, preliminary comments about the process that we've been following. I'd like to make it very clear that our mandate throughout this public review process has been to provide information on the bridge and to solicit comment from the public on the environmental management plan. I should explain that as part of its requirements to complete a final contract with Public Works Canada, SCI is required to complete this environmental management plan. A draft of that plan has been available in the public domain since the 21st of December and will continue to be so until the 29th of January. So that's a total period of approximately 39 to 40 days. And as part of this public review period, we've been having public meetings. We've had 9 of them. We started in Summerside, and I know some of you that are here tonight were there. And we're completing tonight. So those 9 public meetings form part of that review process. We've had these meetings over the past 3 weeks in Nova Scotia, New Brunswick, and Prince Edward Island. In addition to the public meetings, we've had various meetings with interest groups on a one-on-one basis to discuss particular issues or items of concern that particular groups might have. We also have a 1-800 hotline, and if you aren't able to make it to the meetings, you want to give verbal input to this process, you want some information, or you simply want some copies of the documents, then you can do so through that number. We're also accepting written briefs, and that's another mechanism by which you can participate in this process if none of the other avenues are very convenient. Once all of the procedures have been completed, then we'll be revising the environmental management plan, make sure that everyone's comments have been taken into consideration, and submitting it to what is known as Environment Committee. That Environment Committee must approve the environmental management plan as part of this, before this project can proceed, and as part of SCI's requirement to complete the final stages of what is known as financial closure. I'd like to take this, since this is our last public meeting, I'd like to take the opportunity to publicly acknowledge the help that we've had of some of the people that work in the background. In any activity of this nature, there's always some unsung heroes. We get to stand up here on stage, but there's always people working in the background. And I'd like to thank the hard work and dedication of Jesse Davis, Purvi Vishani, and Ellen Tracy. They've helped us quite a bit, and they're working hard to make sure that all of the logistics and the rapportage on this particular process has been completed very effectively and efficiently. I'd like to point out as well, and Jeff will be giving us a lot more detail, that throughout this process we've been very fortunate to have very good attendance at all of our meetings. Indeed, I think we've probably talked to something like 3% of the population of Prince Edward Island. And we're very pleased with the attendance here tonight. I've been told by the stage manager that they tried to get Tina Turner in here one time, but she wouldn't come because she had a very strict diet requirements. That's too bad, because I think all in all, we probably would have outdrawn her. And no one's even seen Paul's legs. This is perhaps an opportune time for me to explain a little bit about Paul's background, which is a relatively little-known fact. Although Paul grew up or was born in Austria and spent most of his life in Canada and the United States, he's actually of Greek ancestry. And the proper way to pronounce his name is Giannalia. So you can understand why most people, ourselves included, just refer to him as Paul. And there's probably an explanation as well why when the CBC chose to enshrine him in PEI folklore, they came out with a song that was entitled simply Mr. G. Well, without further ado, I'd like to introduce to you the president of Straits Crossing Inc., Paul.
Okay. We've actually had a lot of meetings, a lot of fun at these meetings, but it's not fair that at the last meeting I can't even see you. At least in the other meetings I knew who was talking to me and who I was talking to, so it's going to be tough for me to focus my eyes. But ladies and gentlemen, thank you very much for giving us your time to allow us to present our solution for the fixed crossing in the Northumberland Strait. We believe it's a good, well thought out solution, and one of the primary goals of all these meetings is to turn around and get your input to make that good solution just that much better. During the course of our meetings, not only these formal meetings, but meetings we've had in the past with regard to this project prior to Christmas and what have you, and in following the media and listening to people's concerns and reading about them, one of the most common things that came out in all the concerns was that there wasn't enough information for people that were in the community that were going to be affected by this project. There wasn't enough information for them to draw any kind of conclusion based on facts or what was really going to happen. What we tried to do in our presentation that we're about to walk you through is summarize how this project concept solution, or how the project concept was developed, how the contractual requirements were developed, under what criteria we had to turn around and operate under to come up with what we call the best solution that we have in front of us today. And in order to do that, I'm going to walk you through what's the criteria the government of Canada provided for us that we had to meet in order for this project even to become a reality. I'm going to talk a little bit about our project team, a group of experts, specialists, and established organizations that we brought on board to put the proposal together. The design solution, how did we get to it? Today we're saying this is the bridge, this is what we're going to build, what did we go through to come up with a bridge, as well as what to widen out a tunnel. The design verification, no matter how many experts you got on board and how many checks and balances you have, as we've heard at a number of the public meetings, there's also a need to have checks and balances within a group of experts. And I'll walk you through that. And and then show you what the design features are of the bridge that we're going to build, that we're going to operate for 35 years, and hand it over to the Government of Canada, and as a new condition for them to turn around and own and operate it for the remainder of its lifetime, which is a minimum of another 65 years. A lot of people are interested in how do you build a bridge across that water. People that are used to the area look at the water as being something that is always under changing weather conditions. How are we going to deal with that? How do we deal with where we're going to build it from, the construction staging? We're going to touch on those things, as well as a key thing that's has been of concern to many is how much of that dredge or how much of that strait are we going to dredge, and what kind of an impact are we going to have on the valuable fishing community in Northumberland Strait. The main bridge erection is, we're going to walk you through how we plan on building this bridge and how it ties into the environmental concerns of where it has to be built. And then we'll touch on the ancillary works that are associated with the main bridge that's over water. A project of this dimension and where it's being built is going to have a lot of impacts. You've been reading about some of those impacts. What we're going to do is lay out the impacts as we see them, the impacts on the community, the impacts on employment, the impacts on business, the impacts on the economy locally in Atlantic Canada and the rest of Canada. And final, last but not least, what are the impacts that this project is going to have on the environment. At the conclusion of that, Jeff's going to talk about the details of the environmental management plan and how we're going to manage the entire process that you see up there through its life cycle of construction as well as operations. In 1988, the early part of 1988, the Government of Canada established the following criteria for private enterprise to look at providing an alternative, better transportation solution for the Northumberland Strait. And they had the following criteria. First and foremost was that the solution had to protect the natural environment it was going to be in. In our solution that we came up with, that we're going to explain to you, we said that in order to meet that requirement, the best thing to do is when you start with a blank piece of paper, thinking of exactly what it is that you're going to build, you put that on the list of the top priority to always consider in every design and construction solution that you're analyzing. And if you design the structure to be in harmony with the environment, there's a good chance that there's a better chance that it will be at the end of the day. We think we've accomplished that very successfully. Another criteria was that this project had to provide meaningful regional industrial benefits to the Atlantic Canada region. A lot of projects get built that are called mega projects. That a lot of the benefits, the real big dollar items, end up coming from manufactured goods that are manufactured elsewhere. The Government of Canada was concerned that, or made a criteria that in this particular project there had to be significant regional benefits to Atlantic Canada. Our proposal and our solution came up with that we'd end up with a minimum of 70% of the project cost being procured in Atlantic Canada. Another criteria was that the project was going to be financed using private sector financing and result in a net cost saving to the Government of Canada. Our solution and our price charged to the Government of Canada for buying this bridge over a 35-year time period has met those requirements 100%. In addition to that, before the project can start, it's a requirement of the contract that there be full funding prior to financial closing. In other words, that the money needed to make this project happen had to be put in a trust account prior to financial closing. So unlike what has happened on the Hibernia project, where there was a bit of a hiccup because one of the partners was leaving, and it created a question of where's the money coming from, on this contract, the money is going to be in place before we start. That money is going to be put in what is called the project trust account. That trust account is controlled by what is called the independent engineer. We have no control over that trust account. And on a monthly basis, the independent engineer determines what the costs are necessary to complete the project, and he makes sure that that trust account has that cost in it, as well as an additional 10% of that trust for a funded contingency. In order to ensure for the Government of Canada that when the what-ifs happen, what if we have soil condition changes, what if we have delays in weather, or due to weather, what if we have delays due to strike or material shortages, the Government of Canada specified that it had to be what's called cost certain. It is one price, the price is not going to change for any reason, and that price has to cover all risks, or the contractor has to cover all the risks associated with completing the project. Included is what's called date certain. This bridge has to open on October 31st, 1997 or earlier, and if it doesn't open on October 31st, 1997, we're going to keep working on finishing the bridge, and we're going to start paying for running the ferry service. The ferry service costs about $3.5 million a month to run, and it's quite an expensive penalty for not finishing on time. But at least the Government of Canada is ensured that they don't have to pay for any delays created by the project construction. In order to make sure that or satisfy the government that there's sufficient funds available, in addition to having in the project trust account the total funds at the beginning of the project that are necessary to cover the costs, there's also a requirement of the contract that a minimum of 10% addition to the costs that were in or the monies that were in the trust account for project costs had to be placed in the trust account as well. And that became what was called the funded contingency. So before we start, we have in the trust account 110% of project cost funding. In the unlikely event that it's necessary to go beyond the 110% of funds to finish this project, the Government of Canada has required the consortium to provide a performance and payment bonds, and a performance bond in the amount of $200 million. That $200 million performance bond is one of the largest performance bonds ever issued in the country of Canada. In addition to that, behind that performance bond are the corporate guarantees of the joint venture partners, and those companies are very, very large international corporations. As well, the Government of Canada said that there had to be an extensive insurance program put in place prior to project start, and that insurance program includes things like a $120 million policy for delayed startup. There's insurance in place to make sure that if there's delays, insurance policies will pay for those delays so that we get the project done by opening day of October 1997. As well as that policy and many other policies, there's an $800 million third-party liability policy that deals with third-party liabilities and accidental spills and things of that nature. The entire insurance program policies premiums are, I should say, are in excess of $25 million, and we believe they cover the risks from an insurance standpoint very satisfactorily. When we set out to pursue this project, we brought together a team of experts. They're some of the best in their fields in the world, definitely in Canada and not North America. And one of the key things that we took into consideration when bringing that team together was not only their expertise, but to make sure that we developed a working relationship together. The importance of that is any of you that follow sports, pick an all-star team, but if they haven't played together, they don't score too many goals. This group of people that you see on this list have been working together since 1988, which is now getting to be over 5.5 years. It's pretty close. And some of the participants up there have had working relationships far in excess of that. Straight Crossing Inc. includes Morrison Knudsen Corporation from Boise, Idaho, a large international and multinational engineering construction group, and GTM Entrepôts from Paris, France. And the combined revenues and work in place that consortium does on an annual basis is in excess of $6 billion US. The work required to finish the fixed link project and its contract completion, or its contract duration time, represents less than 4% of the consortium's annual workload. So although it's a very large project, it doesn't represent a very large part of the resources of the consortium behind the project. Stanley Engineering is a large engineering company headquartered in Edmonton, Alberta. They're the engineering managers for the project. Stanley works across Canada as well as offshore in the international market. And we've been working with Stanley in excess of 12 years on a variety of projects. J. Mueller International and Leigh Art Andrew and Partners are considered in the top 5 to 10 structural design firms in long-span bridge construction worldwide. And the firm of Leigh Art Andrew and Partners are presently the prime engineers for a similar project being constructed in Denmark. The project uses similar construction technologies as well as design technologies, and it is about 70% complete now, 75%. The only difference, or one of the fundamental differences between that project and our project is it's a little bit shorter. It's 6.6 kilometers compared to our 13 kilometers. Jacques Whitford Environment Limited, they're headquartered in New Brunswick, have been operating in the environmental management or environmental engineering business in excess of 10 years in the Atlantic Canada region, are expert in their field, and have been involved in many of the major projects in Atlantic Canada in the specialty of environmental management. Golder Associates is an international geotechnical firm excuse me, that has been on the team since 1988 and is expert in the field that they operate in, geotechnical engineering. Wind has been a question that has come up in numerous meetings and has been a concern to a lot of people with regard to how much respect we have for the wind in our design, and we take into consideration since 1988 that we've had on our team the Boundary Layer Wind Tunnel Laboratory. That group is headquartered in London, Ontario, and is in the top 5 wind tunneling expert laboratories in North America. Ice is a question that keeps coming up as to how we analyze the ice properly. Do we have enough experts on our team with regard to the design for ice forces and how ice behaves? And since 1988, we've had on our team the Seacorps Institute from Memorial University in Newfoundland, and that organization is one of the top in the world in ice studies, and one of their specialties is, or one of their expert areas is, the understanding of North Atlantic ice. Gordon Capital, has been on the team since 1988 as well. Gordon Capital is Toronto-based. They are currently getting out of the fixed bond market and concentrating more on the real rate bond market. I think things you may have read in the newspapers in the last week have no effect on this particular project's financing plan. Reed Stenhouse is Canada's largest insurance broker. They're part of the worldwide Alexander Group, and their worldwide connection through Alexander allows us to be able to get the large insurance policies that I touched on before. We think it's a first-class team, and we think that because we've had such a long-term working relationship together, that we bring the best of what the industry has to offer to this project. The design criteria on this project was to design a bridge for a 100-year lifespan, design life. What a 100-year design life means is a certain set of criteria that you have to follow in designing a structure. It does not mean that the structure will only live for 100 years. And if designed properly, and more importantly, if built properly, it'll live a lot longer, and maintained properly, it'll live a lot longer than that. In order to turn around and accomplish a long life for this project, one of the things you have to concentrate on is build it right the first time. And the best way of ensuring that you're going to build it right the first time is to make sure that whatever design solutions you come up with, that they're constructible, that they're easy to build. If they're easy to build, there's a good chance everybody's going to do it right the first time. In order to come up with that solution that you see over on the far screen, we did the following analysis of these options. And the analysis of these options was that we did enough preliminary design to understand what our needs were as far as volumes of material, quantities of material were concerned. And we did a costing on each one of these systems and eliminated all the ones you see on the right here to come up with what we call our best and final solution. We studied steel truss and cable stay bridge and priced it out, a steel composite and cable stay bridge, a concrete box and cable stay bridge, a multi-span cable stay bridge, and a tunnel. Those people in the audience that are in the engineering field understand the technical difference between those, but I won't touch on that right now. If anybody has any questions, I'd gladly answer why we excluded the ones that are on this list and ended up with the bridge on the far left. Specifically with regard to the tunnel, the same thing. We were the ones that eliminated the tunnel option. Once we evaluated it, it was not the best option for the requirements of the Northumberland Strait. Contrary to what's been stated by a number of media, it was not the government of Canada that excluded the tunnel option as far as our proposal is concerned. We just didn't think it was as good as the solution we came up with. The solution we came up with is based on proven technology. It's been applied before. It goes to, the structure is from PEI, from the shore of PEI to the shore of New Brunswick. There are no causeway sections. Each one of the abutments is on existing land, and the entire bridge is free from or above existing sea levels. The bridge itself consists of 540 meters of approach bridges on PEI and 1,260 meters of approach bridges on the New Brunswick side. The difference between the approach bridges and what's in between, which we're going to call the main bridge, is that the approach bridges required a different design because the waters are so shallow that the marine lifting equipment that we use for the main bridge couldn't get into the approach bridges. The main bridge itself has 44 piers, 44 spans, each one of them 250 meters long, 250 meters span length, is 42% greater than the span length that the FIRO panel reviewed when they looked at the generic bridge design. One of FIRO's recommendations was to deal with concerns about ice out, is that although they thought it would be more costly, was to increase the span length. And we have that in our final solution. It's 42% greater than the generic bridge. Of key significance with these large spans is that we're able to reduce the strait blockage at the surface to less than 6%. And at the pier foundation, when they sit on the seabed, it goes to 12%. They're cone-shaped foundations, and it increases the overall average is about 7.6% blockage of the strait, which is significantly less than the 10% blockage of the strait that the FIRO panel looked at and said would be satisfactory and have no effect on existing currents and tides. In order to verify for the benefit of all interested parties that the designs are accurate, that they work, that they've been thought through, and that they covered all the requirements of where this bridge is going to live, the following design verification steps have been taken. Public Works Canada has an internal group of experts in-house that is expert in bridge design, and Public Works Canada is the largest buyer of construction services in Canada. For this specific project, they brought on board a group of experts, Canadian and international companies, to work with the internal experts in the review and analysis of each one of the bidders' proposals. That group of experts also had the additional benefit of looking at the other 5 design teams' solutions, the other 5 bidders that didn't get the job, and with that knowledge, they were able to analyze our specific bridge that you see on the left. Internal to ourselves, on each component of the bridge that we developed into our final design, there were 4 independent design checks by different offices in our own group. As well, as some of you may be aware, during the fall of this year, we satisfied ourselves by verifying or satisfy ourselves about the soils conditions and the soils information we based our design on by verifying the existing soils at the exact pier locations where we're going to be building the bridge. And we were out and did a drilling program in September and October and the early part of November at the exact pier locations where we're going to be building. There's 4 holes drilled at each pier location, and the deepest one went 25 meters into the rock. To our pleasant confirmation, we found that the soils information was even better than we had anticipated in our designs, in our proposal submission. And one thing that's of interest to people concerned about dredging, we found less overburden than we'd anticipated earlier on. I'll be touching on that a little bit later. One of the concerns that was raised in the FAIR panel, and probably I guess most would agree, was the number 1 and major only concern of real significance was the effect that the bridge would have on the natural 65-day phenomena of ice out in the strait. And they were concerned that it could have an effect once in 100 years of between I believe it was 10 days or 2 weeks, and in response to their concern, Public Works Canada put together a group of experts, some of the best in the world in their field, what became known as the PWC Ice Committee. That Ice Committee looked at our design and each component of it and satisfied themselves that our design would not have an effect on, would not have the 2-week effect on the ice out, the normal ice out phenomenon, and the ice out effect would be less than 2 days. In addition to all those checks and balances, there is a body enshrined in the contract called the independent engineer. His first job was to produce a preliminary report on the design and the costs of our design and our cost of the project. In order to satisfy himself on that design, he went through his own checks and balances and brought his own experts on board, and he did the same to check our construction costs. One of the things that was a real significance for him on that side of it, on the construction cost, to make sure that there was enough money, is because he had to, on a monthly basis, verify how much money was needed left to finish the bridge. In order to assist him in that and to make it easy for him to do that monthly job of approving how much money needs to be left in the trust account to finish the job, we broke this job down into 10,542 individual work activities. Each one of those work activities was broken down by an additional 30 cost parameters of the type of cost that go into them, including whether it was a laborer, a carpenter, whether it was a cubic meter of 40 MPa concrete or a cubic meter of 50 MPa concrete. So this project is broken down into tens of thousands of little components, and so it became very easy for the independent engineer to follow through to make sure that all the costs that should be anticipated for the project have been, and that the total project cost amount is accurate. The independent engineer will issue a final report on when the final design is complete, and as the design, before construction drawings are being produced, he is going to turn around and approve each one of them. On an ongoing basis, he's going to verify the quality assurance and quality control programs that we have implemented on the project construction that is being followed. Once the project construction is finished, the independent engineer is going to live with us for the next 35 years, and monitor to make sure that the long-term maintenance, the regular maintenance and taking care of the bridge is being carried out according to our contractual long-term maintenance plans. When people say, well, how do we know that we're going to end up with a bridge in an as-new condition 35 years from now? The answer is that one, we have a contractual requirement to do it, so that's the first thing that you can count on. And secondly, we have an external independent engineer who's going to make sure it gets done. So we feel fully confident that built into the contract process, there are sufficient checks and balances to ensure that nothing's being missed. The main design features of the bridge are listed on the overhead to your right. And first of all, which is very significant, it's an all-concrete structure. And the significance of that is it's a low-maintenance structure. And especially in a marine environment, it's one of the best structures you can build when it comes from the standpoint of long-term maintenance and longevity of the structure. Because the people of Canada are going to take over this bridge 35 years from now and operate it for the rest of its life, the low-maintenance component of the structure itself is a very important design feature. Moving over to the people that are the users. The user of the bridge, you and I, are going to approach that bridge and we're going to see that there's extensive traffic signalization and communications. And as you go across that bridge, you're never going to be alone. For the following reasons: the bridge itself has this traffic signage which is electronically controlled from a control center stationed in Borden on a 24-hour basis. And that control center will advise you what's up ahead of you, whether there's an accident, a stalled car, the wind speeds that are occurring at any given time, because the bridge will be 24-hour under wind control. And should you have a problem like a flat tire or something, every 500 meters there'll be a telephone along that bridge, so you'll never have to walk more than 250 meters to make a phone call to the emergency control center to send somebody out to help you. In addition to that, the entire bridge structure is on closed circuit television 24 hours a day, much like a security system in a bank building or something. 24 hours a day, that entire road surface is on television. That television monitoring goes back to the same control center, and somebody's watching you all the time. Should you have a problem, like let's assume you run out of gas or something, as you're drifting off to the side of the road to pull off the driving lane, the person that's in the control center is going to know you got the problem, but at the same time, you know you got the problem. And that's important for people to understand that you're never alone on that bridge, and somebody's always watching you. It's not a good place to go parking, and or it may be a good place to go parking, I don't know. But, with regard to pedestrians and cyclists, many people have asked the question in the past, but just to clarify it, you are not allowed to walk across the bridge, and you're not allowed to pedal your bike across the bridge. But what happens if you want to get to the other side, whether you're walking or pedaling your bike, there's a 24-hour bus service that's going to take you, and if you got a bike with you, you and your bike, to the other side. The main reason for that, or I guess the only reason for that, really, that we can think of is that purely safety. We don't want people walking out on that bridge by themselves, and so it's one of the requirements. You can't walk across that bridge. In the event that you are somebody who wants to get to the other side, but you don't like driving your car across the other side, because you just don't like driving over a bridge, we will, at your request, drive your car and you to the other side for you, and that's something that will allow people who don't feel comfortable with driving a bridge to get to the other side. In addition to that, there's going to be from the control center tied into local AM stations on its own frequency, the ability to get updates on what's happening on the bridge, what are the wind speeds today, and is there any maintenance going on the street or on the bridge or what have you. In order to control the concern about what if we have that jackknife tractor trailer, fuel truck jackknife on the bridge and crash and spill, we've established a dangerous goods control, which means that all dangerous goods have to be escorted across that bridge with pilot or escort vehicles. Those escort vehicles are going to have on them boom safety equipment that in the event that the vehicle, let's say this was a truck and a jackknife and started leaking, that you would put a boom across at the front of it, the back of it, with your front vehicle and the back escort vehicle, and it will control the spillage within the confines of where this truck is spilling the fuel. The only fuel that would end up in the strait is that small amount that would go through the drainage holes that are there at regular intervals for natural bridge drainage. And those will be manually closed after the accident happened. The reason we say in the unlikely event that would happen is because by controlling dangerous goods across that bridge, and they'll be traveling at very low speeds, approximately 20 kilometers per hour, that particular journey for that vehicle carrying dangerous goods is going to be the safest journey in the entire highway system in Atlantic Canada. At 20 kilometers an hour, if there's a blowout of that vehicle's tires or something, it's going slow enough that the driver will be able to control the vehicle and not worry about jackknifing or what have you. In the event in that unlikely event that there is an accident with that truck of dangerous goods and it explodes and there's a fire, what will happen is that the fuel that's burning will burn off and not go into the strait. The people will get out of the way naturally. The emergency vehicles that will be there 24 hours a day dedicated to the bridge will be called out, and they include having jaws of life equipment as well as firefighting equipment. One area that has been talked about and written about a fair bit is wind control. How do we know that the wind isn't going to blow all the cars off? Well, there's going to be a 24-hour wind control on the bridge, and the type of control will include the following. At approximately 40 kilometers per hour winds, there's going to be wind warning signs posted, and large vehicles will have to slow down, or all vehicles will have to start slowing down. Will have to slow down by regulation, by signage, and when you get to 70 kilometers per hour, large vehicles will be forced to slow down by using escort vehicles. And when you get to 100 kilometers per hour, cars and loaded trucks will be escorted across the bridge, and empty trailers and empty vans and empty campers at 100 kilometers per hour will not be allowed to cross that bridge. The winds are, I should say, 100 kilometers per hour. Wind study analysis has been done show that the time when empty trailers, campers, and empty vans cannot go across that bridge due to winds in excess of 100 kilometers per hour is 35 hours per year. One of those hours is in the summer, and I believe 24 is in the winter months, and the remaining are in the spring and fall. Should the winds get past 118 to 120 kilometers per hour, where we get into what's getting close to being classified by Environment Canada as hurricane conditions, when that happens and if it becomes unsafe to drive across that bridge, yes, we will be forced to shut the bridge down for safety reasons. There's 24-hour snow and ice removal service on that bridge, and the dedicated snow removal and ice removal equipment that's dedicated to the bridge only will allow the snow removal to start the minute the snow starts falling. And by doing that, there will be enough equipment on site on a full-time basis to keep up with the snow removal. In the unlikely event that the snowfall is so great that even that dedicated snow equipment cannot keep up with the snow removal, one of the things is for sure that there will be no vehicles even getting to the bridge to try to get across it, because both sides will have a lot more snow on the roads than the bridge. However, the analysis and study we've done with regard to the snow equipment, the quantity of snow equipment, removal equipment we need, is that we don't ever anticipate getting in a situation where we can't keep that bridge clear. The question has also come up at times about ice removal, and the reason, and ice removal because of the ice formation from breakers coming down during heavy storms in the winter and the spray ending up on top of the road deck. And one of the reasons that this bridge deck is 40 meters above water is to avoid exactly that. That it's high enough that it can't be affected by the spray effect of high, or during storms of high breakers. In the unlikely event that the breakers get high enough so that the spray gets high enough, we're all going to have a bigger problem than trying to worry about the ice on the bridge. The second part of the reason that this bridge doesn't ice the same way as the icing on normal bridges you're used to locally, where they say the bridge deck ices before the pavement ices, excuse me, is because the bridge being so high above surrounding terrain is not affected by the differential temperature of this surface and the road surface, and so it's up in that air high enough that it's relatively immune from that phenomenon. Where it's necessary to de-ice the bridge, de-icing salts will be used. One area where a lot of people have mentioned concern in the past has been the area about the fear of traveling so high above the water. So what we did for the benefit of everybody is a bridge height comparison, this being the McCabe Bridge in Halifax, this being our main bridge, and this being our navigation channel, hump in the bridge that occurs in the middle of the bridge. To put it in a perspective, when you're traveling across the McCabe Bridge, you're traveling at 52 meters above the water. Although the towers are higher where the road surface, that's 52 meters above the water, compared to when you're driving on the main bridge at 40 meters above the water, so you're actually 12 meters lower to the water surface than you are traveling across the McCabe Bridge. However, when you go over the hump in the middle, you're traveling at 64 meters, so you're going to be traveling 12 meters higher than you travel across the McCabe Bridge. Anybody who's traveled across the McCabe Bridge and feels comfortable doing that is not going to notice the difference traveling across this bridge. However, a much more important reason of not seeing the effect of traveling at that height is the following. Go back one slide. For safety reasons, these concrete barriers are continuous along the entire length of the bridge, and they're at about a height that if you're in a sports car or a small car, you'll just see over the top of them if you look to your left or right, and you'll be looking into the horizon. If you're in a normal car, you'll see a little more of the horizon, but you won't be seeing the water. Once you get up to the size of a pickup truck and up, you're going to turn around and be able to not only see the horizon, but be able to see the water in the distance. And so you're never going to get the feeling as well, unlike the McCabe Bridge, there's emergency shoulders, so you're further away from it. You're never going to get the feeling like you're looking straight down. So there, your sight lines as far as looking left and right if you're traveling across that bridge in a car are not very good as far as you can just see the horizon. However, when you get to the top of the hump in the middle of the bridge, whether you're, let's say you're traveling from here to New Brunswick, you get up to the top, you'll be able to see 180 degrees of the New Brunswick shore from that vantage point as you start coming down the other side. So as long as you're looking ahead, you'll be able to see a very good panoramic view of either New Brunswick or PEI. We think it's a very user-friendly bridge, and stress again that you're never going to be alone on that bridge, and that's going to provide you a better safety environment traveling those 13 kilometers than any other 13 kilometers in the existing Atlantic Canada highway system. A question before I leave your drivability, a question came up one of our meetings about, well, what about whiteouts? and if you're out there in the winter, you got whiteouts. And simply put, whiteouts happen when the snow that's that's lying adjacent to a road surface gets blown up by winds and just totally whites out the area in front of you. Because this bridge is so high above, and this is ice now during the winter, because it's so high up, the phenomena of whiteouts is going to occur a lot lower than the 40 meters above. So whiteouts in itself is not going to be a problem. In studies, not studies, but I guess monitoring has been done on a similar structure, similar from the standpoint as far as its height, and as well as it happened to have a causeway section on the Mackinac Bridge in Michigan. They had to close that bridge for whiteouts a few times in its 30-year life to date, but the whiteouts only occurred at the causeway section, again, because that's where the snow is allowed to pile up on the ice beside the causeway. We're high enough above it that we will not experience a whiteout problem. Our construction methods are based on standard, proven technology. Everything we're doing up there has been done before. The only difference is some of the pieces are a little bigger than what's been moved around before. But all the work and the methods we're using is proven standard technology. Our goal in developing our construction methods was to minimize our marine activities and maximize our land activities to reduce as much as possible the construction schedule's dependency on weather. We also had the goal of maximize the utilization of existing local labor skills. By ending up with an all-concrete bridge, we feel fully confident there's more than adequate labor skills available in Atlantic Canada to form and place the concrete and lift concrete components into place. And in order to turn around and satisfy all the requirements and making sure that we don't have any accidents, our construction methods include very extensive safety and training programs. Those safety and training programs will also include training for environmental management of all of our staff so that they become aware of environmental issues during the construction stage. The main project office is going to be Charlottetown. That's the corporate head offices of Strait Crossing Consortium. The main design office is going to be in Moncton. The procurement and employment office, they'll be duplicated in Moncton as well as in Charlottetown. They'll also be further duplicated at the construction office locations in Bayfield and in Borden. So if you're looking for a job, it'll be relatively easy for you to turn around and get a job without having to travel too far. Definitely you won't have to travel off the island to apply for a job, and vice versa. Somebody applying for a job on the mainland won't have to travel to the island to apply for a job. The things that Kevin put on the screen at the left was a rendering. Let me back it up a bit, Kevin. One more. This is the existing CN station, and we've had extensive ongoing discussions with the owners of the station, CABC, to see if it's feasible to put together a solution for renovating the station for the future, and in the short term, while we're operating or while we're building the bridge, for us to become the tenants of that station, turn around and offset the renovation cost and end up with a structure that has other uses in the future. With regard to assembly yards, the assembly yards are going to be located in Borden is the main assembly yard, as well as another assembly yard is going to be at Bayfield. And Slemon Park facilities will be used for the purpose of training. The hangar facilities will be used for live mock-up training of different forming and rigging systems. For those people that are familiar with the Borden area, this is the ferry terminal, existing ferry terminal. And that piece of land that sticks out here to the east of it, what's shaded in that is what is going to become our PEI staging area, and that's the main staging area for the construction of the main bridge. It's 150 acres of real estate. We're going to be building a wharf to deep water. That wharf will include the ability to sink submerged barges here to the sea bottom, so the barges are sitting on the sea bottom when they get loaded with the bridge components. This particular wharf requires approximately 150,000 cubic meters of rock fill. Over here is where that wharf takes off into the water. This is an area where we're going to be fabricating what we call the pier bases. The shafts, the pier shafts will be fabricated in this area. The main bridge girders will be fabricated in that assembly line. And the drop-in spans will be fabricated there, put into storage, and then they get moved from the staging, or from their storage area out to the barges. We'll talk about that in a moment. In order to prepare the site for the project, or for the components, the segments themselves, we've got to prepare the foundations. Foundation preparation is that work that's required underwater and in a marine environment. In our solution, we need to dredge at only 44 pier locations, which from a distance standpoint represents less than 12% of the total distance across the strait. And our dredging starts at 540 meters offshore and ends up 1,260 meters from the New Brunswick shore. There's no dredging required for our approach bridges, because they're in such shallow water that they're going to be drill piles rather than gravity-based structures. The amount of time we expect to spend at each pier location is approximately, on the average, 6 days, and we expect to finish the dredging in less than 2 years. The dredging quantity on the average is 5,900 cubic meters per pier location, for a total dredge volume of 260,000 cubic meters. That 260,000 cubic meters compares to the 300,000 cubic meter plus, I believe it was, that the FERO panel report reviewed with regard to the generic bridge, so this is an improvement over that as well. The FERO panel also concluded with proper dredging techniques that the amount of sediment produced by the small quantity of dredging would not have a harmful effect on the marine environment. To put it in a perspective of what 260,000 cubic meters of dredging means, we gave you some comparisons of quantities. Between 1980 and 1982, there was 4 million cubic meters of dredging in the Miramichi estuary. In 1985, in the Summerside Harbor dredging, which happens on a regular basis, there was 450,000 cubic meters of dredging in one marine season only, compared to our 260,000 over 2 years. The annual Northumberland quantity of dredging for maintenance dredging is 300,000 cubic meters per year. This dredging is not over a total of 2 years, it's just a little over 1 year, so we'll be in there for 2 seasons, but not the full 2 seasons. Once we get to, we have the seabed level and dredged, we're going to be putting in leveling beds of clear stone aggregates on which we're going to place the pier base. This structure here you see is a structure similar to what we'll be using, which is used in the project I mentioned previously in Denmark. They bring a barge up to the rig and it unloads right onto the rig, and it's all automatically places and compacts what we call the foundation bed, which is about 750 millimeters of clear stone. Once the pier base is put in, the scar protection goes around it. All that material is using imported clear stone, so it will not have a negative effect on the environment around it. I spoke earlier about minimizing the number of marine activities and maximizing the amount of land activities. The total project requires 427,000 cubic meters of concrete to be cast. With our design and construction method solution of the total concrete placed on the entire project, approximately 20,000 cubic meters of concrete will be placed over the water during the construction of the main bridge. A very small quantity of the total will be placed in the marine environment, and in addition to that, that concrete that will be placed will be in the form of closure pours. There will be very many pours where the pieces come together, and each one of the pours will be a very small quantity. The key significance of that is that in the unlikely event that we do have a breakage in our concrete pump equipment or what have you, the amount of spillage will be very, very minimal. The concerns raised by people saying that during the construction you run a great risk of damaging the natural marine habitat. We believe we've managed against that in the way we've developed our construction methods. The entire main bridge only consists of a total of 183 bridge components. Those bridge components consist of a pier base, a pier shaft, a main road girder, and a drop-in road girder. And I'll describe those in a moment. To actually place one of those, to actually do the activity of placing them into their final position, takes approximately 1 day. And so if you look at that, you say, well, in theory, you could finish that project in 183 days. Our analysis of existing wind and weather information in Northumberland Strait says that with our equipment, we have between 185 and 188 working days on the strait, what we call weather working days, I should say. So the amount of time we're going to spend on that strait equates to one marine season to put up that main bridge. It will not be built in one season because there are a lot of steps that go in between placing one piece and placing the next piece. But we don't have the kind of storage capacity to build it, all the entire bridge and store it and then erect it. To be built over 2.5 seasons to 3 seasons. And so the point we want to stress is there's going to be very, very little work happening over the marine over the marine environment, and there's very little chance of affecting the marine environment. At any given time in the staging area, there's going to be 19 segments under construction, and that's going to be the largest labor force of the entire project. Will be in the production of these 19 segments. In storage, there'll be storage capacity for 54 segments. So in the unlikely event that we get a long term of bad weather, we'll have sufficient storage capacity so that the production of the units can continue while the marine equipment is waiting for better weather. What you see on the left here is the project we mentioned in Denmark, which is similar. This is a typical, what we would call a main bridge girder. To put it in perspective of how this size compares to what we're talking about, these main bridge girders are 110 meters long, and our main bridge girders are 170 meters long, so ours are just a little bit longer. Where these are all in storage, and you'll see a similar situation at Borden where these units will be in storage, and then our lifting mechanisms may be different than that, but that's the kind of, what you see there is what you see at Borden. To move those pieces around the storage yard and out to the load on the barge, what we're going to be using is what we call a Lamson transporter. This is a crawler unit that travels on existing ground. Put it in a perspective of size. What you have down here is a 3/4 ton pickup truck. This unit has a 4,000 ton capacity, and there'll be 2 of these units. They're going to pick up each piece and move it around the site and from storage out onto the submerged barge that we mentioned. You may have seen similar technology when you watch the space shuttle being moved out to the launching pads, where they have large crawlers like this that turn around and move it along to the launching pad. This equipment has been used extensively in many applications. One of the more common ones It was used in Alaska a lot for hauling prefabricated components for the oil and gas industry across the tundra, where you have changing terrain and it's large enough to be able to handle those variations. Once we get out to where we want to place the pier base, we're going to have a barge or a crane mounted on a barge that's going to turn around and lift the pier base off the barge that brings it out, the load barge, and lower it into the sea. These pier bases are of such up varying height so that when they get placed in the bottom of the ocean, the seabed, they'll always be sticking 5 meters out of the water. So there'll be varying heights to take care of the different sea floor elevation. The maximum height is approximately 150 feet, the equivalent of a 15-story building, or I guess it'd be a 20-story building, but that order of magnitude. On top of that, we put the pier shaft. At the navigation channels, we have 2 of these to put into place. And on top of that, to the top of the shaft goes what we call the main span girder. The main span girder is 170 meters long. It is 50 feet high right here at its deepest point, and it weighs 7,600 metric tons. This crane, which is mounted on this barge, from the sea level to the top of that crane is the equivalent of a 35-story building. And on a clear day, you will see that crane boom from many, many parts on the island. That crane has the ability to take that 7,600-ton piece of concrete and place it 62 meters in the air on top of the pier shaft. Because this concrete base, when it gets placed, ends up being 5 meters out of the water, there's no need for any underwater concreting. So again, we have reduced the interface between the marine environment and underwater concreting in that environment. In conclusion to that, we think it's a pretty simple method of building a bridge. We're not going to be out there that long, and the things we're going to do out there are things that are very clean as far as running the risk of spills of concrete equipment breaking down and what have you. The picture we have on the left, they're a shorter span because they're only 110 meter long pieces compared to our 250 meter pieces, but it gives you an idea of what the shape of this thing is going to look like. Our pier spacing is more than twice this pier spacing. This is 110 meters and we're at 250 meters. But the shape of our girder is the same shape as this. This is not quite as high as our girder, so we're going to be a fair bit higher because of the longer spans. But it's that kind of a shape that it'll take. In addition to the main bridge, we have some ancillary works. We have to build approach roads in New Brunswick and PEI, and we have to turn around and build approach bridges in New Brunswick and PEI. Because of the shallow waters that these approach bridges are going to be in, we can't use the big marine equipment which we just showed you. So in those shallow waters, 540 meters of that, before we get to deep water on PEI, and 1,260 meters of that on the New Brunswick side is going to be built in what we call precast segmental construction. On the left here, I don't know if you can see it, it seems to be a little fuzzy. Now these are piers for a bridge that we're just finishing in Hawaii called the Windward Viaduct, which is being built in precast segmental construction. Now once the piers are built, these are the units that get cast in the staging area, and then they get lifted onto the bridge from above using a launching truss. Not working? Huh? That's too dark. Okay, sorry. In addition to that, we're going to be building dangerous goods stations on both sides of the water, toll plazas, administration and maintenance facilities on the side, on the PEI side, and another ancillary work is there's an option to rebuild or replace the Hillsborough Bridge, which may be exercised by the government of PEI. So what does all that mean and what impacts does it have on the community? Studies have been done and shown that in the long term there's going to be increased employment opportunities. The fishery community is going to be compensated through what's called the Fisheries Compensation Plan, which is a plan that's going to be administered by the Fishery Liaison Committee, a committee that is chaired by the Government of Canada and is made up of representation from the fishing industry in the Northumberland Strait. We're going to end up with a more improved transportation system, and that's going to result in lower transportation costs. It's going to result in increased export opportunities. It'll increase the size of the market area that'll be available to PEI businesses to compete in, and it'll come up with more convenient and predictable travel as a 24-hour system. We walk you through how you're going to get across that bridge, and we're going to end up with a new corporate head offices for the bridge operating company in Borden. That's going to add to the tax base of the town of Borden. We're also going to end up with substantial transfers of technology during the life of the construction, as well as after the construction period is over. We'll be touching on that more during the question and answer period. Some ancillary benefits that are going to accrue to the community are things like when we're in Borden, we're going to turn around and require consistent water supply for our needs. At the end of the construction, the facilities that we've built in, that infrastructure, could be available to the town of Borden if they so choose. There's a series of those kinds of benefits available there to spin off this project. Most important, not maybe most important, but one of the key things is there's going to be reduced and predictable toll increases. According to our contract with the Government of Canada, the toll increases are fixed based on the toll rates at the time of, or at 1 year before the bridge opens, the existing ferry toll rates, and they're going to be allowed to grow at no greater than 3/4 of the consumer price index. Our toll revenue formula will be like a regulated utility, and as a result, it'll be more predictable. If that same formula had been in existence for the last 10 years, between 1982 and 1992, our toll formula would have increased the toll rates by 34% during that same time period. The consumer price index actually grew by 46%. However, what you see in the red here is autos, or the toll rates for autos on the existing ferry system increased by 79%. Trucks toll rates increased by 93%, and passenger rates increased by 160%. In total, over that 10-year period, to get across that ferry cost you 107% more than in 1992 than in 1991, compared with 34% if the fixed link formula would have been put in place. From a dollars and cents standpoint, what does that all mean in dollars? The people, the users of the ferry system during that 10-year period would have saved $14 million. And you can see each year how the savings increase. And so if you extend that graph, it's only going to get worse with the existing toll rates that are on the ferry system. The impacts on employment are obvious. There's going to be in excess of 1,000 new jobs created during the construction. Jobs that are Atlantic Canada, the large experienced labor force can supply. They're going to be jobs that you're all familiar with, jobs for laborers, carpenters, equipment operators, marine crews, specialty trades, engineers, and managers. in order to follow on how you get those jobs and the job training and everything else, it will all be laid out in what's called the Human Resources Plan, which is being developed between ourselves and the Government of Canada and the local provincial governments, labor people. Impacts on business. We talked earlier on today about what's called the Regional Industrial Benefit Plan. We are committed to produce a Regional Industrial Benefit Plan that provides 70% of all work or all cost. 70% of total project cost is going to be spent in Atlantic Canada. This includes $245 million for equipment, materials, and supplies. And the Regional Industrial Benefit Plan will lay out the new business opportunities that could be possible. It's going to lay out the procurement bid packages, and during seminars we'll advise and teach everybody how to go about pursuing business opportunities on the fixed link. The type of purchases that we're going to be making, we're going to require over 1.5 million cubic meters of aggregates and stone. That does not include the aggregates necessary for the production of 427,000 cubic meters of concrete. We're looking at 200,000 tons of cement, 53,000 tons of reinforcing steel, 12,000 tons of post-tensioning steel, 8,000 tons of miscellaneous metals, 139,000 tons of asphalt, and we're going to use in excess of 15 million liters of fuel to build the bridge. Now, those are what we call the big ticket items, but in addition to those, there are many, many things that are included. Included in the $245 million, there's many things that are non-construction related directly, but indirectly they're business related. One of the things that we're going to require is we're going to require in excess of about 150 computers. Those computers are going to require maintenance. Those computers are going to require training of people, so there's going to be the ability for training businesses to computers to get business on the fixed link, maintaining computers. We're going to require over 100 pickup trucks. We're going to turn around and, like everybody else, require haircuts and what have you. So it goes all the way down to everyday businesses are going to require or are going to have the opportunity to participate while this construction is going on. Today we live in a global economy, and that's not going to change. It's not going to go backwards. We're not going to be able to shut out the world around us. We're not going to be able to shut out the world on the other side of Canada. We're going to have to compete in that global economy. And the competition for goods and services is increasing every year. Just recently, there was the borders between the provinces, the economic borders have been removed, and the Atlantic Union scheme. A little while ago, North American free trade came into existence, included Mexico, United States, and Canada. It wasn't that long ago, I believe it was about the time when we were looking at this project in its early stages, that we were arguing about should there be free trade or not. And for our country, the long and the short of it is our global world is becoming more and more of a reality, and therefore we have to be able to compete on a more global basis. Compete, one of the things we have to do is we have to reduce government debt. Our debt that our governments are carrying is far too excessive, and it makes us very non-competitive when most of our taxes go to servicing debt rather than producing infrastructure and new things for the country to allow us to compete. This project and its financing formula results in savings to the taxpayers of Canada as well, and what's more important in our opinion is that it's going to be a privatization initiative model for the future. The way that this infrastructure need that traditionally was done by governments on government debt is being financed by private enterprise, and the government is paying for it over a 35-year period, not much unlike the way you pay your mortgage. When you turn around and get a 35 or 25-year mortgage, you pay for things over time, doesn't increase your debt overnight. Solution for future infrastructure needs is going to create more work opportunities. We're struggling right now to come up with enough funding for the twinning of the Trans-Canada, and the debate goes on that however much funding we've been able to come up for the twinning, it's insufficient. It's insufficient. We don't have enough money. So this model for the future, we believe, is not only going to provide us more infrastructure construction, it's going to provide us more work opportunities. Atlantic Canada, right now, 1993, not next year, but right now in 1993, is going to help put the Atlantic Canada economy back to work, and it's going to allow people to get back to work. And anybody who's without a job knows it's much more fun working than it is talking about someday going to work. The impacts on the environment. Much has been talked about, and there isn't a common consensus on it, no question about it. With regard to the extensive reviews by all parties, from our standpoint, we've followed this project since 1987. We believe there's been extensive reviews by all parties of the environmental issues. We've stated that before, and we produced a proposal and a scheme and a solution that is in full compliance with all environmental requirements and the various steps that we have to go through from here on in to get through the final environmental review process we will be undertaking, as Jeff will talk about later on, and it'll be in full compliance with all environmental requirements. From a global standpoint, we think we're going to help the global environment a bit. We're going to reduce the amount of fuel that is going to, the emissions from the fuel that goes into the atmosphere once we eliminate having to turn around and run the ferries. As well, there's going to be no future impact on the environment for new utility lines to the island. Inside the bridge structure is included a utilidor, so that in the future, future utilities that are required to come over to the island, what's going to happen is that they're going to be built inside of the concrete box of the bridge, and that utilidor is going to replace the need to put any more utilities on the sea bottom. Once the ferry system disappears, what we're going to end up with is the real estate that the ferry runs on, that exclusion zone, will become available to fishermen in the area on a full-time basis. We understand that right now there's restrictions on certain types of fishing, not others, but all you got to worry about is make sure you don't hit the ferry while you're fishing there, so this is going to be a plus for the fishing community. And in order to make all of that happen, the construction I just walked you through, and to make it happen in an environmentally safe way and to deal with the environmental concerns of the people that are actually doing the building, Jeff is going to turn around and present the environmental management plan highlights. I would just like to summarize, though, that I know it's been a long story, and I don't know how long I've been talking. I always get heck for that, but it took over 5.5 years of a lot of people's time analyzing a lot of studies that were done before we, as a consortium, even got involved to put together what we tried to summarize or highlight for you here today. What I'd like to share with you is that what you've seen today is the tip of an iceberg of the amount of information that was analyzed, developed by a lot of experts to get to where we are today. We feel fully confident that we have a very good solution, well thought out. And if there was one advantage that all these delays have created, it's allowed us the opportunity to keep looking back at it, and looking back at it, and looking back at it. But I think we're in a position now where we can confidently say we've listened to the concerns that people have raised in writing, in reports, even in the media, and we've taken those concerns and we've incorporated them into our design and technical solution, and we're ready to go to work and build you a bridge that we know we're going to take care of over the next 35 years, because if we don't take care of it, our maintenance costs go up too high. We know once we've taken care of it, as long as you take care of it, that bridge is going to live a lot longer than 100 years. So, ladies and gentlemen, that's our bridge.
Thanks very much, Paul. You'll just be patient for another 15 or 20 minutes, ladies and gentlemen. Jeff will give us an overview of the characteristics and components of the environmental management plan. Thank you.
Thank you, Jacques. I think I'm going to stand on this side of it. My task is to discuss the draft environmental management plan and try and give you some insight and an overview as to what that contains and what it's all about. And I have to emphasize for you that it is a draft environmental management plan. We're here tonight to get your input so that we can make it a better plan, and I'll elaborate on how I see that being done. I emphasize as well, we are talking about a plan. It is an umbrella document in a sense that it outlines all the different components and things that we have to do for the life of the project to manage the environmental affairs of the project. Before I get into the details, I want to review for you some of the highlights of the review process that Jacques touched on briefly. First of all, we released the draft environmental management plan on the 21st of December for a 39-day review period, and we've had 9 public meetings. This is the last of that group of 9 in both New Brunswick and PEI, as well as 1 meeting in Nova Scotia. We've had a number of meetings with interest groups at various times through the same time during the day and so on with these groups. We've been accepting written briefs, and point of fact, if any of you would like to jot down your ideas or present a formal brief, just speak to the people who are at the table outside after the meeting, and they will give you the address so you can send it to us. As well, we have a toll-free number where you can call us any time if you don't want to write it down. You think of something tomorrow when you get home and say, geez, I should have asked that, or I should have suggested this. Just give us a call and we will record that suggestion as well. At the same time as doing this public review, Public Works has established an environment committee, as it's referred to, and that's comprised of Public Works, Transport Canada, Fisheries and Oceans Canada, and Environment Canada, as well as the Departments of the Environment of Prince Edward Island, New Brunswick, and Nova Scotia. And they are right now reviewing the document as well. And they will be taking the results of this public consultation and their own review and providing that to us to help us develop a more effective environmental management plan. Before we can proceed, before we can actually secure a contract with Public Works Canada, the Environment Committee must accept this document as an acceptable environmental management plan. And that's a key. It's a condition of signing the contract. As this is our last meeting, I just did up some statistics today, and just to review for you the extent of the public meetings that we've had. We've had 9 meetings, and I just roughly estimated while I was sitting down waiting to speak, we have about 500 people here, I think, tonight or so, and that brings our total up to about 3,300 people we've spoken to in public meetings. We've also spoke with 18 interest groups to date, approximately 2,000 people involved in those discussions. Some of them were just 2 or 3 people on one, and some were quite large meetings, as some of you know. What it really totals to is we've been face-to-face with about 5,300 people in the last about 2.5 weeks. To give some idea on the extent of distribution of the document, through a number of different channels, we have distributed over 1,000 draft environmental management plans. Quite a thick document for those of you who've seen it, and there is a copy at the table at the back, reference copy to look at, and if you give us your address, if you want a copy, we'll send one to you immediately in a post tomorrow. As well, we have a summary document which is a bit shorter, and we distributed over 2,000 of those, totaling, I guess, over 3,000 documents distributed. Just one last point on our consultation. Earlier this week, we talked to our 1-800 number person, and she tells us that we've had about 550 calls with the result of 910 documents being distributed just through that mechanism alone. I'm going to talk a bit about the management plan in general terms. First of all, the management plan is composed of a number of different elements and different tools. They're divided basically into 2 main groups. the sort of protection procedures and related activities, and then the monitoring side of things. As you see from this diagram, we have environmental protection plans and environmental reporting procedures, contingency planning, and so on. Employee environmental orientation education, regulatory approvals and permits are all integrated with that. And then we have environmental effects monitoring, all of which I'm going to speak about in a little more detail. The last thing there, public information and consultation. SCI recognizes that after we've done this round of consultation, the exchange of information does not stop. It must not stop. To develop an effective management plan that lives through the life of the project, we have to have continuous dialogue with various interest groups, fishermen, naturalists, and so on, to make sure that that exchange is consistent through the whole project. I'm going to talk now about the environmental protection planning, and this is really the cornerstone of how we implement protection procedures effectively on the job site and also at the bridge during operation. Now, an environmental protection plan is really a procedures manual. I've often referred to it as a rule book or a cookbook almost of procedures on how we are going to conduct the work or how we're going to operate the bridge from an environmental perspective. And if I can give you an example of that, it covers a number of different things, but let's take, for example, there's a lot of concern in the marine environment about various species of fish and shellfish and so on, and a concern like the timing of construction in relation to something like herring spawning. One way to minimize any possible effects on herring spawning would be to try and schedule your work so that you're away from the herring spawning beds. And so that would be incorporated in the planning, would also be articulated as a measure in the environmental protection plan. Now, if you know here, contingency planning, what this involves is quite a wide range of things. It can cover things like what if you come upon historic or archaeological resources? What do you do? How do you deal with that? Who do you contact? What are the procedures to follow to ensure that they're not disturbed before an archaeologist can assess the situation? And it can range to things like forest fire protection planning, and as contingency planning, and as well the more obvious, if you had a loss of fuel and had to be cleaned up and so on, there'd be plans in place for that sort of thing. Now, related to that is knowing who the key people are, not only on the job site from an environmental perspective, but also the regulatory authorities or other people who have environmental knowledge. And in the protection plan, all those people are identified, so for quick reference in case of the need to talk to people. Reporting procedures are really important. If you've ever been on a construction site, sometimes nobody seems to know what's going on. And from an environmental perspective, if you're going to build a bridge effectively and protecting the environment, you have to make sure everybody does know what's going on from an environmental perspective. And that means that you have to have reporting procedures established, and you also have to educate your employees on environmental affairs. And if I point to that, I'll point over there. The employee orientation and education is really a key implementation aspect of our plan. If you don't tell people how they're supposed to do it, they won't do it, they won't know how to do it, and they won't know they're supposed to do it. So every single employee who comes onto the job site will receive an environmental orientation program, a briefing. And that will involve viewing a general video that everyone will see regarding the receiving environment and the sensitivities and the concerns, the fact that there is an environmental protection plan, the fact that every single employee has environmental responsibilities. And then following that, depending on what work area or what their jobs are, the environmental staff will meet with those people and brief them fully on their responsibilities under the environmental protection plan for their work area. As well, the regulatory permits and approvals and authorizations that have to be gotten under the various environmental legislation, they will be integrated into the environmental protection plans and planning, and they will really form an integrated protection planning procedure. The last thing I wanted to mention regarding protection plans is that SCI will have a dedicated environmental staff on the site, and that, when I mean dedicated, that means that their sole job will be to deal with environmental affairs. They will go around the site and inspect activities. They will interpret the environmental protection procedures for the workers. They will also offer advice when something comes up that maybe we hadn't planned on, and just generally keep an eyes out for making sure that things happen the way that we want them to and the way we've committed to undertake them, both in our own planning and also under the various regulations and permits. Give you some idea of how we coordinate this protection planning. If you look at the draft environmental management plan, the last half of that thick document is what we call a generic environmental protection plan. And during the planning phase of the project, we have prepared this document, and it is really the standard environmental protection plan procedures that will apply to most of the job site or all the job site. And we have that out for review now. Based on that, and also our interpretation of the work activities and how they relate to the environment in the key work areas, we are developing right now as what we call stage-specific environmental protection plans. And those 3 work areas for the construction phase are the staging areas, the land-based construction like the approach roads and abutments, and the marine construction. And the reason why we're doing that is because workers who work in those areas tend to work only in those areas. There's not a lot of interaction between them, and we want to focus their attention on only those things that they need to know regarding their areas. And we also want to be in as much detail as possible discussing and presenting those facts. As well, towards the end, we are going to, at the end of the construction, we're going to develop an operational environmental protection plan, and that will deal with all the environmental affairs of operating the bridge in an appropriate way, particularly things like contingency planning for unexpected environmental accidents. I'm going to shift gears now and start talking about monitoring, and that's, you may recall from the umbrella environmental management plan that was one of the key points. And this is the scientific aspect of dealing with the environmental affairs of a project like this. And I think the best way to explain what environmental effects monitoring is to tell you why we would do environmental effects monitoring, why we would do these studies. And there's 4 key points which are all related to each other that are the reasons for actually undertaking it. The first one, evaluate effectiveness of protection measures. I mentioned in the protection procedures, we have a number of measures that we're going to implement. We want to make sure that these have been effective, that they continue to be effective. If they're not, then we want some kind of an early warning of their lack of effectiveness, and that's the second point. If there are any undesirable changes in the environment, we want to be there to monitor it and have some feedback and complete that loop so we can change our plans, come up with new ways to deal with that particular problem to ensure that we effectively mitigate any potential effects. On a more scientific side, there's often a lack of information on how a project like this or the activities associated with it actually affects certain components of the environment. So sometimes we do environmental effects monitoring studies just to improve our knowledge of those relationships. And lastly, related to the earlier ones, confirming impact predictions. During the environmental assessment and our own evaluation of our activities, we made a lot of predictions about what the likely effects are on the environment. And it's very important that we go back and monitor our activities to ensure that indeed our impact predictions were correct, and if not, then have that feedback loop to take corrective action, as I mentioned earlier. Now, excuse me. Obviously, if there's scientific studies, it makes it a little difficult sometimes because it's hard to do good science. And some of the key ingredients to doing a good environmental effects monitoring program is ensuring that indeed they are scientific studies, that they have proper research design and methodology and sampling and so on, so that answers can be gotten regarding the possible effects with the appropriate statistical certainty. As well, they have to be practical. Sometimes scientists can think of a lot of good ideas about how they'd like to study something, but it's difficult to collect the data. So you have to develop practical methodologies, and the study has to be practical. Lastly, and a very important component is that there have been a number of studies on various components of the environment, but we want to know what data are available, how good is that data, and if there are any data gaps, can we collect that information so that we can conduct the study and get the answers that we want to satisfy those objectives that I mentioned earlier. Now, as the effects monitoring are really scientific studies, the thing that we want to do is we want to get some external review of our activities. SCI has a lot of expertise available to it, as Paul mentioned, to develop terms of reference for these kinds of studies, and we're actually working on that in earnest right now to try and develop good scientific studies to address the objectives of our program. But we wanted to get some kind of external review, so we are going to be, by the end of this month, appointing an Environmental Effects Monitoring Advisory Committee, and that will be comprised of scientific experts from research institutes and government and the consulting environment, and possibly from the public as well. And we want them to advise us on whether or not our draft terms of reference for the studies are indeed satisfactory. Are we studying the right things? Are we going about it the right way? Do we have the appropriate research design, and so on? So we really feel that's an important part, and that Effects Monitoring Advisory Committee will guide us through the life of our monitoring program. To give you some idea of the things that we're developing terms of reference for, I refer on the terrestrial side, the terrestrial being the land-based studies, for which we will have one particular committee. There are a number of concerns, particularly the Cape Germain National Wildlife Area, but also on the Prince Edward Island side, Noonan's Marsh and Amherst Cove Marsh, have a number of species such as waterfowl and shorebirds, and over at Cape Germain there's the salt marsh aster, which is a rare plant in New Brunswick, which is of concern, and osprey and the common tern. So we're going to be developing terms of reference for these, and they'll be available shortly, and by mid-February we're planning to have a workshop with our Environmental Effects Monitoring Advisory Committee to discuss the merits of the draft program. On the marine side, you can see there's a lot more things that we have to deal with, and it's really the real key, or the most important area of the project environment interactions. And there's 4 areas that we're looking at: the ice climate, fisheries resources, the physical and chemical oceanography, and then there's a number of species that, or components of the ecosystem that we're interested in monitoring. Everything from pelagic and groundfish like herring and mackerel and so on, to things like phytoplankton, which are the small one-cell plant that are at the bottom of the food chain, or an important component of the food chain. And you'll see a number of other species, like commercial species like scallops and oysters, and some which aren't necessarily commercial but are of environmental or ecological interest. And before I close, I want to review what's happening with our environmental planning from a review process. Many of you are well aware of the fact that there was a federal panel, and they reviewed what was called a generic bridge concept, or bridge concept assessment. What we've done is we've compared our specific bridge proposal to that generic proposal, and we've identified the differences that are between our proposed project and the generic, and we've also provided more details on some of the things that were not available to the committee or to the panel, I should say, when they did their review. And what we've done is we've included that information, that comparison, and those details in an environmental component report. That's what that component report contains is an evaluation of the importance of any of the differences that we've identified between our proposal and that which was assessed during the federal panel review. And in particular, the panel did not know very much about the specific proposals of the staging areas. So we give quite a lot of detail on our Borden and Bayfield proposed staging areas, and we evaluate those activities in relation to the surrounding environment in those areas. And we've developed and outlined protection measures for inclusion in the environmental protection plans. And lastly, we've made suggestions regarding monitoring for inclusion in our environmental effects monitoring program. The reason why we've done all this exercise is to help us plan, but also we have some regulatory requirements that are relevant I want to touch on. In both Prince Edward Island and New Brunswick, there is environmental impact assessment legislation. In Prince Edward Island, it's the Environmental Protection Act, and under that legislation in both provinces, a project of this nature is required to be registered for consideration by the regulatory authorities. And we have prepared registration information in response to the requirements of that legislation, and we provided with that registration a package of information which includes the environmental component report and as well, of course, the draft environmental management plan. At the same time, the environmental component report has been provided to the Environment Committee that I mentioned earlier that was struck by Public Works Canada, the group that is responsible for reviewing and accepting the environmental management plan, and we provided that to them in support of their evaluation of our draft environmental management plan. That's my last slide, but just in conclusion, I'd like to state that dealing with the environmental affairs, particularly on the construction site, but also on a bridge operating, the actual environmental protection is a very straightforward exercise. It's very practical and pragmatic. It's very much like construction. Paul's construction people break down the activities and plan things out in a stepwise fashion to build a bridge, and the environmental protection has to be developed in the same sort of way. And it's a very pragmatic and practical approach, and we've tried to keep it that way and develop a way in which all the workers understand what their responsibilities are when they're working either on the construction or the operation of the bridge. And with that, Jack, I'll pass it back to you.
Well, thanks very much, Jeff, and thanks very much, Paul, before that. And thank you, ladies and gentlemen, for listening so attentively. I think compared to some of the places we've been in the last couple of weeks, you're one of the better behaved audiences. Maybe that's because the seats are a little more comfortable. I'd like to move right away into the question and answer period. Because there are, as Jeff mentioned, 500, I think there's probably a little bit more, but there's a lot of people here and we'd like to get through this effectively, so I would ask that you observe a few simple rules. The first one being that we use the microphone so that we can hear you, and that way we can answer your question, and I'm sure everyone else in the hall wants to hear you as well. Because there are so many people, I'd ask you also to be precise. Now, I appreciate that this project engenders strong feelings, one way or the other, and I would encourage you to channel those emotions into intelligent, well-crafted, and thought-provoking questions. I'm a maritimer, and I've been very pleased with the reception that the audiences have given Paul and his colleagues, and I'd very much like to see us go out on a high note. Without further comment, I noticed that his worship's at the microphone, so I'd like to offer him the courtesy of being the first speaker.
Thank you very much, Chairman Jack. I don't have a specific question. I have about a 2-minute comment. Distinguished guests, ladies and gentlemen, mega projects like the Fixed Link will have a terrific impact on our region generally, but more specifically on our capital city, Charlottetown. We were excited at City Council in '88 when the notion of a fixed link became more than a pipe dream. We were elated at City Council in '92 when Premier Giz announced that his 10 points were satisfied and that as far as he was concerned, the link was a go. Charlottetown will benefit tremendously. We will have SCI headquarters in our city, and we should and we will be the pulse of the project. This development is an economic injection into areas like real estate, transportation, travel, tourism, and entertainment. Facilities in Holland College and UPEI very easily be utilized as an integral part of the project. Our downtown businesses will blossom because of this explosion in spending. The city's unemployed should see a reduction in numbers. There will even be a psychological impact on the unemployed. At least there will be a renewed hope of work. Charlottetown's demographics will change as a result of the mega project. There will be a provincial in-migration to the city core because of the presence of the head office, which of course is responsible for hiring. This in-migration to our urban center will impact upon our housing and rental business like never before. The Charlottetown business community is extremely optimistic about this project. I was able to detect that optimism from the 915 people who attended today's Chamber of Commerce luncheon at the CP Hotel with Mr. Paul Gianelli as a guest speaker. The City of Charlottetown is proud to have SCI's head office located here. The City of Charlottetown is pleased that the fixed link project has injected renewed interest in our business community. As Mayor of Charlottetown, I welcome the fixed link and thank the organizers for the opportunity to speak.
Thank you, Your Worship. I'd like to mention as well that we're here to attempt to answer all of your questions. We're not going to shy away. I mentioned at the outset that our mandate was to give you some description of the bridge and the environmental management plan, but you can hit us with anything you have. We're also prepared to stay as long as it takes to make sure that you have a satisfactory answer. Every other place we've been, we've never closed the meeting down. The audience has closed it down. Now, unfortunately, that's meant that in having 9 meetings and 9 working nights, we never got to bed before 3 o'clock. And I don't know about the others, but I'm starting to feel like an old rock star. We're going to go this way, up and around, I guess that's counterclockwise direction, and we'll start right with you, sir, and Kevin, you help me out with mics. Thank you.
Okay. My name is Roland McKinnon. I'm here not representing anyone in particular except myself. I don't represent any interest groups of any sort. But I do have some statements to make. Most of what I'm going to say is rhetorical, but reply if you wish. I can't help but thinking that I'm witnessing a repeat of history here. Reading island history, which I do with great interest, I can't help picturing that at the time of Confederation, in order to draw the island into Confederation, great promises were made about a connection to the mainland, ferries, a railway, the railway going into the Atlantic provinces and into PEI. This was going to solve the economic burdens that we all carried at that time. The fact of the matter was that at that time, the 3 Atlantic provinces were probably the richest provinces in the country. Manufacturing just on this island, machinery, ships, 400 vessels registered under PEI. You talk about global trade, PEI was globally trading at the time of Confederation in a very large scale. True of all the Atlantic areas. So we bought into this. We got the railway, which is going to make it better. What happened? The economy didn't come to us, went away from us. Not just because of the railway, admit it. But it went away, never to return. We're looking at a project here where people are saying and claiming the same thing. I'm saying it's not coming back. I'm not opposed to jobs in this island. Matter of fact, God knows I need as many as I can get myself. But I am opposed to the rationale as to how we get them. For you people to put up $1 billion plus interest, allowing for overruns, we're talking somewhere down the road of something in excess of $2 billion, plus a subsidy of $40.2 billion, which over the period of time of the 35-year period starts looking like $1.6 billion of public monies. Problem there is, I don't think very many of us in here tonight know what $1.7 billion is, most of which will be leaving this island and not coming back as well. What we're talking about here, what the mayor talked about, is very short-term employment with some spin-offs into the economy and supply and services. We're looking at $1.7 billion of taxpayers' money gone. Now, I'm going to attempt, I saw an interesting thing here a couple of weeks ago, I'm going to attempt to explain in general terms, or terms I think we all understand, what that kind of money represents. $1.7 billion would buy all the franchises of the NHL. It would buy 5,000 Wayne Gretzky's, 5,000 Mario Lemieux. It would give every Islander a $40,000 a year tax-free income for life. It would build the best ferry service in the world and pay off the provincial deficit. That may be an exaggeration, but that's the kind of money we're talking. Take that same money and put it into other aspects of the island, the ones the tourists live. The land, the water, the fisheries, the beauty of this island. Keep that, put that money in those areas, do a lot more. Sell a lot more lobsters for some people too, at exorbitant prices. That project across, I'd like to make a comparison. Although we're talking about a different structure, the rationale of the economics involved here. The English Channel, as they call it, they broke through from France and England. We met in the middle here a year or so ago. When they broke through, they popped some champagne and had a party. Several days later, the ferry companies operating between France and England put out some of the biggest contracts for new ferries that had ever occurred. Because when they saw the final figure with the overruns and everything else, they laughed and said, "We've got it made, order some ferries." Now,
Well, excuse me, Roland, do you have any idea how long it might be? It's already been 5
well,
minutes.
now just wait now.
You can come back to the microphone as many times as you like. But there are people stacked up all over already.
I'm almost finished.
Good.
For quite a while now, we've been hearing about all the
Let him speak. Let him speak.
We've been hearing about spin-offs. And I'd like to say, you know, the CN station restoration, another span across Hillsborough Bridge, the Irving Whale thing, training workers, fishermen's comp, the whole thing. There seems to be no end to it. All the gratuities and so on tied to it. The irony is, at the same time, what's been said in the media and from other official sources is warning people, if somebody makes you an offer that seems too good to be true, it probably is.
Okay, thank you, Roland.
I'd like to make one final statement, if I might.
Okay, one quick one.
One final statement. The matter about spray and ice on the bridge, and because you're 40-some meters high, it will not occur. I'd like to remind you that last year on this island there were quite a number of power blackouts, in some cases lasting days. Those power blackouts were not due to storms per se, but it was due to ice spray, you can check with Maritime Electric, ice spray going right across this island, condensing on electrical insulators and so on, and shorting them out. And here you are out in the middle of the strait, not going to get any ice. I think you're wrong. Thank you.